Here we're going to look at solving a system of equations by adding or subtracting and effectively using an elimination method. So the question is, what is the solution to the system of equations? And we are given two examples. So one of the things we're allowed to do, and I'm going to rewrite this system here, is you're allowed to combine terms from, say, separate equations. And what that looks like is you can add vertically. So I can add the x terms, I can add the y terms, and I can add the constants over here. All right, so you're allowed to add up each of those three columns. And we can start by doing x plus 2x, and that would give us 3x. And then y plus negative y just gives you 0y. Now, we don't need to write that, so we're not going to write that in. We're just going to leave that empty space there. And then we're going to add 7 and 2. And now we have 9. So what we've done is we've eliminated the y value from our equations. And that's why it's called elimination. So we now have an equation with one variable, so we can very easily solve this for x, and we get x is equal to 3. Now that we know what x is, we can go back into the original equations, substitute x, and solve for y. It will not matter which equation you choose. You can choose the first or the second one, but usually there's one that's slightly easier. Not always the case. In this case, equation 1 will be a little bit easier. So I'm going to take x plus y equals 3. I'm going to keep x plus y equals 7, and I'm going to substitute my x value with what we solved for previously. So now I have the equation 3 plus y equals 7. I can subtract 3, and y would be equal to 4. So my final answer would be 3, 4. Now you can box in the x equals and the y equals, or you can box in just the coordinate point. Usually you would write your final answers as coordinate points. In example B, we're going to look to do the same thing or something quite similar. Now there is kind of a school, actually I'll get to that in a moment. Let's use the other process that we can use. So we have our system here, and what we're allowed to do is we are allowed to either add the equations or subtract them. Now this is going to be incorrect, so don't do this next step. If I was to add these up again, I'd get 10x plus 4y equals 6. And the problem here is that nothing has actually been eliminated. So addition doesn't work. So that tells me that I should not use addition. However, if instead I subtract my equations and do 4 minus 6, I get negative 2x. 2y minus 2y is 0y, which again is eliminated. And then 4 minus 2 would be equal to 2. Now, when you're adding, but especially when you're subtracting, you have to be very careful with your signs. So we would then solve for x. Again, I can't stress that enough. Be very, very careful with your signs as we're doing these problems. So x is equal to negative 1. Now, if I go back to my original equations, they're pretty similar. So I'm just going to use the first one. I'm going to say that 4x plus 2y is equal to 4. It doesn't make a huge difference which of these equations you decide to use. So plug in your x value and solve for y. Make sure I'm doing operations in the right order and with the right operations. So we have a final answer of negative 1, 4. And that's my solution. Now for these, they're pretty direct when they're set up nicely for you. You'll see in a later video what to do with something called equivalent expressions or equivalent equations, equivalent systems, which you'll see in example 2. But what you want to do here is you want to look to identify whether you should be adding or subtracting. To make that decision, If your values are the opposite, so here we have plus y minus y, you're going to add your equations. In part B, our symbols are the same, right? Plus 2. So there you would subtract. So the note to yourself is that if they are opposite, you would add, and if they are the same, you subtract. Now there is a school of thought that has you always add, but to do that in part B, you would have to multiply an entire equation by a -1, which you'll see something similar in example 2, but I found it a little bit easier just to recognize whether you should add or subtract and not worry about changing signs before you do so. All right, it is up to you. Again, subtraction is kind of the same thing, so hopefully there's no issues with that.